In this lesson, we will derive formula to measure distance between 2 points A and B in xy plane. Let's assume that the given points are, the given points here, given points are A with coordinates x1, y1 and B with coordinates x2 and y2. If distance between them is denoted by, if distance between these points A and B, distance between A, x1, y1 and B, x2, y2 is denoted by D, A point and B point. Then we will find the value for this distance. So let's get started and assume that the point A is arbitrarily given over here somewhere and name it as A, and coordinates are already given x1, y1, and the other point B is given here and its coordinates are given x2 and y2. Now for coordinates of A, x1 is abscissa and y1 is the ordinate. As you know that abscissa is always distance from y-axis. Distance of point A from y-axis, which are labeled y-axis over here, is x1. So let's get started and label this distance as x1. From here to here, this is distance x1. And y1 is this distance from point A to the horizontal axis, x-axis. So this is our distance y1. And similarly for the point B, this horizontal distance starting from here to the point is x2, and if we draw this line to indicate this is the point. And similarly vertical distance, because the ordinate of point B is y2, therefore this distance from here, this distance must be y2. So let's continue this line, and this is y2. Let's call this as y2. Distance from that point to x-axis. Now if we complete this triangle between point A and B, this direct distance from A to B is in fact the distance we want to measure. But if we make a triangle here, this is the base of the triangle. Let's name this as point M, and this as point N, and this as point T. A, M, N, T is a rectangle. And if we want to find out the sides of triangle A, M, B, for finding sides of triangle, A, B, M, we will find the side AM, and AM is is, in fact, if you take a look on these distances here, this distance from here to this is x1, from this to this point, and this distance, just for the clarity, this is x2 from here to here, and that's why we have distance, this distance from here, x2 minus x1 up to this point, this is x2 minus x1. So AM, which is in fact equal to Tn is equal to x2 minus x1, x2 minus x1. So we can label this distance whether directly or indirectly, it is x2 minus x1, that is length of the base of the triangle. Similarly, the height bn is y2 and at, which is in fact equal to mn, is y1. So bm, which is what we want, is equal to bn minus mn. And now if we take a look, bn is equal to y2. This is y2 minus y1. Therefore, the triangle, this side has y2 minus y1. y2 minus y1. This is length of this side of the triangle. And now we want to find out the side AB, the hypotenuse. So this is hypotenuse, and this is equal to base, and this third side is, you can call it opposite or perpendicular. And by applying Pythagoras theorem, by use of Pythagoras theorem, what we get is, what Pythagoras theorem states is, hypotenuse square is equal to base square plus perpendicular square. Now what is hypotenuse? Hypotenuse is given, that is AB square is equal to base. What is base of the triangle is AM, and you're going to write square plus perpendicular is BM, and now we are going to use the values of AM and BM. This is equal to x2 minus x1 whole square plus y2 minus y1 whole square is equal to AB square. So AB square. And we know from the inverse operation, if we want to undo the square, we can take square root on both sides. This will give us AB distance is equal to x2 minus x1 square plus y2 minus y1 square, and then square root, and we know that the distance between AB is denoted by DAB, whether we write it like AB mod or we can write it this way, but anyway, this is x2 minus x1 square plus y2 minus y1 square, and square root is, this is required formula for finding distance between 2 points in xy plane, and we can always find this distance as long as we have coordinates of both of these points.